Okay, so in the previous class, we have seen the basic like concept that. Just a moment. Yes. So in the previous class, we have seen like how we can go with the basic introduction to the semiconductor devices and what are the different concepts that we will be requiring in throughout this class. So we have gone through the basics, and in previous class also we have discussed the course syllabus. So we will proceed with the energy bands, basically how the energy bands are defined in crystal structure. So to proceed with the energy band, we will start with a basic like element by considering any of the three, any of the four, like whatever elements are there. We can call it like a semiconductor elements or any element we have considered. Sorry. So in that, these elements can be represented according to its atomic number. Okay, according to its atomic number, different cell representations are there. We represent an element with its atomic number with different levels of energy, and that is written like different energy cells are there. So you might have gone with different cells are there, energy cells are there. Okay, so these energy cells have different you can say S, P and D levels are there. Okay, so in that different whatever electrons available into this, whatever atomic number is there with respect to that, these cells are filled with the number of electrons. Okay, so this representation has been given in case of carbon, silicon, germanium and Sn, that is 10. Okay, so carbon is having 6 atomic number and its representation is like that. So if we see closely, it is like in the first cell. Okay, so first cell is 1s2, that is 2 electrons are there in the first cell. The second, that is cell is there, that is 2s2 and 2p2. So that means total 4 electrons are there here in the last, or you can say outermost, you can say cell. So in the silicon also, the outermost is 3s and 3p. So in that, here also 4 electrons are there in the 4 cell of germanium. Basically here 4 electrons are there. Okay, so generally we have considered only those elements that is having its outer electrons are having, outer cell is having 4 electrons. Okay, so basically here with respect to that, we will see like a crystal is there that is formed by different atoms. Okay, so suppose this is a crystal structure is there, by forming different atoms, by connecting different atoms, we are having a crystal. We just want to analyze like what will be the effect of the distance. So the distance between these atoms are like suppose d. So if we are going to vary this d, we are going to vary this in distance, that is called interatomic distance. Okay, so we just want to analyze like what will be the effect of varying this interatomic distance between two atoms, if two atoms of any of the element is there, and if we are going to vary its interatomic distance, what will be the variation on its energy band. Okay, so how this energy band can be represented and how this interatomic distance is going to affect the energy bands basically. Okay, so here whatever most of the metals and semiconductors are there that are crystalline in nature. Crystalline in nature means this crystalline in nature means there will be these whatever atoms are there, that is arranged in a regularly, you can say, an orderly manner. So this orderly representation, orderly, you can say, combination of atoms to form a crystal is basically called a crystalline metal or semiconductor. In that, the crystals or the atoms will be arranged in an array, that is a regular array will be there, pattern will be there of atoms and molecules, so that representation will be a crystalline representation. So that in the crystalline uh, metal or semiconductor, basically we are going to vary the distance. Okay, so suppose we are going to vary the distance. So what happens if the interatomic distance is far apart? Okay, that means t is very high, and if the d is very small, then there will be this arrangement of the crystal, and this arrangement of crystal will be behaving differently. Okay, so its behavior will be changed with respect to the distance between these atoms that is placed into the crystal. Okay, so when atoms basically form a crystal, it is basically found that the energy levels, whenever these atoms are going to form a crystal, it is found that, like, whatever energy levels are there, that is inner atoms are inner cell electrons are there. So these inner cell electrons, like one atom is there and it is having different energy. So whatever outer energy is there, that is 4 electrons are there. uh, Instead of this 4 electrons, whatever inner electrons are there, so these inner electrons will be such that that will not be basically, suppose one atom is there, this one, and another atom is there, and it is having also the 4 outer electrons. So if two atoms are placed close, uh, whatever placement is there, if it is placed too far apart, then this outer electrons will not be affecting each other's performance. But if we are going to place these two atoms uh, closer to a sufficient distance or enough distance, the characteristics of these combination of atoms, that is a crystal, so once we are combining atoms, it will be forming a crystal. So that crystal property will change with respect to the placement of these atoms. Okay, and in all the cases, like whatever inner electrons are there, so it is like 1s2, 2s 2 and 2p6. So these are inner electrons. So outer electron is 5s2 and 5p2. So if we are, even if we are changing the distance, then also this inner electrons will not be, you can say, basically participating in the changing property of the crystal. Only the outer electrons will be affecting the crystal property. Okay, once two atoms are being closer or far apart. Okay, so basically we are going to analyze this 4 electrons are the outer electrons of the two atoms that are being made closer to each other. Okay, so that we will be analyzing. Okay, so now we will see like different cases. Like if we are going to place two different atoms uh, with respect to the distance, what will be its properties. Okay, so here, suppose we are having a case 1. So in case 1, we are saying like atoms are like far apart. लाइक एटम्स के बीच का जो डिस्टेंस है दैट इज बहुत ज्यादा है, ठीक है। इफ डिस्टेंस इज वेरी फार अपार्ट, what will be the characteristics? Basically we will see that. Okay, so if atoms are far apart, that means the interaction between the atoms will be negligible if the atoms are placed far apart. Okay, so the interaction between the two atoms will be negligible. Basically that means interaction means whatever interaction in terms of electric field or whatever atomic interactions are there. So interaction uh, between atoms is negligible. Okay, so here interaction between the atoms will be negligible if d is very high. Okay, so the interatomic distance is very high, the interaction will be negligible. That means if interaction is negligible, that means suppose whatever energy level is there of the outer electron, the same energy level will be of this atom and this atom also. That means if we are combining these two atoms to form a crystal, the energy level will be having a synchronized value, or we can call it a coincide value. That means the same value will be there. Whatever energy level of atom 1 is there and atom 2 is there, the same energy level will be there. ठीक है, दोनों का energy level same होगा. Okay, that means with respect to this concept we can see this figure like figure A. So here अगर जो इंटरएटॉमिक डिस्टेंस है वो ज्यादा है, ओके, दैट मीन्स इंटरएटॉमिक डिस्टेंस अगर बहुत ज्यादा है, इन दैट केस whatever energy of the outer electrons are there, so whatever outer electrons are there into the atom, that will constitute to an energy level. So that energy level of that these both atoms will be equal if the distance between these two are very high. Okay, so here this will be representing the energy of the S and P states. So it is like 2s states will be there, 2s states are having 2n electrons, and 2p uh, uh, basically 6 electrons are possible in p cell. Okay, so that means 6n will be there, the states of p cell. So 6n states will be there for p cell. Out of that only 2n, that means 2 electrons will be occupied, okay, out of this 6n. Okay, so at the higher distances these energy states will be coincide with each atom. So whatever each atom is having, the energy will be coincide. So now what we are going to do is we are going to move to the left, like we are going to reduce the distance. Okay, so now we are going to reduce the distance. So initially it was like we have placed two atoms far apart. Now we are going to reduce the distance. So once we have seen like the far apart atoms are there, the interaction will be very less. Once the interaction is very less, their energy level will coincide. We can write like energy levels will be coincide with individual atom, or we can call it isolated atoms. Okay, so if these are having coincide energy level and such that The coincide energy level is such that like 2n states, 2n states will be occupying 2n electrons, okay, and 6n possible s states will be occupying 2n electrons, okay. So here this is also clearly visible into the figure, okay. So second case we will see. So now what we are going to do is we are going to make the interatomic distance closer, like the distance between two atoms we are going to reduce, or we can say like atoms are made closer, okay. So we are going to move the atoms closer, okay. So if we are going to move the atoms closer, then what will happen is basically whatever atom is there that we are going to make closer, these atoms will exert an electric field on its neighbors, okay. So like the distance we have reduced, so initially distance was larger, now we are going to reduce the distance, okay. So if we are going to reduce the distance, that means there will be an exertion of electric field. So atom, so these atoms will basically exert uh, an electric force. So these atoms will exert an electric force on each other, okay, such that the atoms will form like a coupling atom. So these two atoms are the neighboring atoms that will exert a force on each other. So these atoms will form a coupling atoms. That means that will be having a close relation. So these two atoms or the neighboring atoms will be somewhat interacted with uh, some electric force, okay. So that means some electronic behavior will be shown. So whatever electronic charge, so some outer electrons will be interacting with another outer electron, so it will form an electronic system. So these atoms will form an electronic system, okay. And these electronic system will be such that whatever 2 and s states are there, s states, that is outer s electrons are there, so 2 and s states uh, will be interacting with each other. That means the outer electrons will be interacting like suppose this is the crystal, these are the electrons, outer electrons, okay. So some interaction between the electrons will be taking place, okay. So these interaction in terms of energy states will basically change uh, the the energy state. So this was the energy state when the distance is very high. Once we are going to reduce the distance, these energy will spread. So the you can say the range of these energy levels will spread as the outer electrons are going to interact with each other. Okay, so basically, so here two n states, two n s states will interact with each other. So instead of a steep line, the energy states will spread now. Okay, so spreading of energy state will be taking place. So this uh, two n states is going to spread out. Okay, spread out in energy. Okay, that means whatever energy state was there previously, it was like the atoms are far apart, so energy state was a straight line. So energy states of the one atom and another atom are at the same level, but as the atoms are made closer to each other, the energy state will be interacting with each other, and it will be spreading out and form a band type of structure. So initially it was same energy state was same. As we are going to reduce the distance, the energy will spread. Okay, and it will form a band, like it will be having a minimum value and a maximum value. Okay, so here the atoms is having energy levels that is having some maximum value and some minimum value. Initially the maximum minimum was same. Okay, but here once we are going to reduce the distance, it will be forming or spreading the energy levels such that it will be having maxima and minimum. So here energy uh, here the energy bands are the states as states are basically going to spread out, and it will be having different. So these spread out, the energy will be spread out, and this spread will be having a maxima and minima. So this spread will have a maximum value and a minimum value. That means initially it was like a straight line. Once we are going to reduce the distance, the energy will spread, and it will be forming a maximum and minima. Okay, so here it will be maximum, this will be a minimum. Okay, so this is the case as we are going to reduce the interatomic distance. Okay, so these are basically the large number of discrete energy levels. Okay, so these are different discrete energies are there. Okay, so these discrete energies are spreading out with some energy level. That energy level is basically, in case of this energy level, will be in electron volts. So this maxima and minima will be having a range that will be in electron volts. So these energy levels are basically called energy bands. So this spread will result out to a energy band. So previously it was having energy level. Now once the interatomic distance are being made closer, the interatomic distance are made smaller, the energy lines will spread and form a discrete energy levels. So these collection of these discrete energy levels is basically energy bands. Okay, so here in case of this, like the energy levels are there. So here two n states in this case, basically in this band, two n states are being completely filled with two n electrons. Okay, so here two n s states are basically filled with two n electron, and the 6n state is filled with uh, 2n electrons. Okay, so here we are not going to say like it is 2n states of s and 6n states of basically. So like it is being formed by combination of S states, all these S states. So individually it is not the individual S state, it is basically the S state of the crystal, or the different S levels of different atoms, the two or more atoms that are closely related, that is going to form crystal. So it is the property of now a crystal. Okay, and one more term is there, like energy gap. Okay, so we will see like what is an energy gap is there. Okay, so next we will see what is a energy gap. Okay, so basically this energy gap is also called forbidden gap, we call it. This is basically the energy gap between two atoms. This is two bands basically. So this is energy gap between two bands. So whatever energy gap between two energy bands are there, that will be your uh, energy gap. Okay, so this the distance or the difference of energy levels between two bands is called energy gap. So energy gap basically decreases with atomic spacing. Like, so as in the previous figure we have seen like the energy gap basically decreases as we are going to decrease the atomic distance. So you can write like this energy gap decreases with increasing the with the decreasing the atomic uh, spacing. Okay, so here energy gap decreases with atomic interatomic distance decreasing. So as we are going to decrease the d, that is interatomic distance, the energy gap will decrease. Okay, now with respect to that, this fourth case is there. We are just basically going to change the interatomic distance and what is the effect on the crystal, that we are going to basically analyze. Okay, so here in the first two cases we have seen like initially the far apart, and then we are reducing it to some smaller distance, interatomic distance. Now further we are going to reduce the interatomic distance. So here we are reducing the d interatomic distance such that uh, the bands basically overlap. Okay, so we are going to reduce the such that the bands are overlapped. So what will be the crystal property that we are going to see? Like if the d is made smaller enough such that the bands are overlapped. Okay, in that case what will happen is like the 6n states and the 2n states will basically merge. Okay, so the 6n states and 2n states now will be merged. Okay, and after this, when these two are merged, it will be After merging, it will be like total 6n plus 2n, that means 8n states will be there. Total n 8n states will be there. Out of this half, that means 4n will be occupied by 4n electrons, like 4 electrons are there, 2p and 2s electrons. So out of this total 8n states, 4n states or 4n states will be occupied by 4n electrons. Okay, so we have made D such that the bands are overlapped. Okay, so bands are overlapped. We have reduced this D such that the bands, because once we are going to reduce D, energy gap will reduce. So we have made D such that the energy gap is no energy gap is there. That means the bands will overlap. So in that case, this will be the possibility, like the 6n state and 2n state will merge, and out of this 8n states, half of the 8n state, that means 4n states will be occupied by 4 electrons. Okay, so here 4 electrons are basically, so this 4 electrons, now once the merging has been taken place, there will be no s and p type states. So it will be like, once it is merged, it will be behaving like a crystal. So it will be the crystal property. So whatever 4n electrons is filled, so these 4n electrons that is filled will be part of the crystal. Okay, it will be a part of the crystal as a whole, not p or s states. So initially when D was large, the energy levels were defined by the P state and S state. Once it is made closer such that overlapping of bands is there, then that will form a crystal. In that, the energy level will be defined with respect to the crystal. So 4 and that means half is occupied by the uh, crystal level and 4 is empty. Okay, so now here in this crystal 4 electrons are there, that is filled. So that means these uh, 4 n electrons will say that the element, so this 4 n electrons will say like this element formed by two crystals of an atom is having 4 n electron filled. So these elements are called tetravalent, because as it is going to contribute 4 electrons to each atoms of the crystal. So here, because 4 electrons are shared by two atoms, so the element formed by this uh, two crystals such that it is sharing 4 electrons, so this 4 electron sharing will make is a tetravalent element. Okay, and and as 4 n electrons are being occupied, or 4 n states are occupied and 4 n states are empty, so these occupied 4 n states is called valence band. Okay, so once the atoms are made closer, such that it is going to form a crystal. In that crystal, the number of states that are occupied by electrons are basically called valence band, and the and empty states is called conduction band. Okay, is it clear? Okay, so next we will see the fourth case, like how the further we can reduce the distance such that uh, the next point of you can say energy band as a whole to a crystal can be defined. We will see that. Okay, so here case 4 we will see. So here if we are further going to reduce the interatomic distance below the overlap point, okay, so we are going to reduce we are going to reduce d beyond band overlap point. So here we are going to further reduce the distance beyond the interatomic distance such that the energy bands have overlapped. Okay, so beyond this overlap point we are going to basically reduce the distance. So in this case here basically the interaction between atoms is going to increase as we are going to further reduce the distance. So here the interaction between atoms is very large. Okay, so interaction between the atoms are going to be very large. Okay, that means it will basically affect the energy band. So between the two atoms, if we are going to reduce the interatomic distance beyond this overlap point, the energy band structure will be depending on some parameters. So now here, so in this case the energy band will depend on two different parameters. So one is like, so here action is going to be very large. The energy band will depend on the one parameter that is called orientation of the atoms. Okay, so whatever orientation of the atoms are there relative to one another in the crystal, that will be defining the energy band structure. Okay, so orientation of the atoms in crystal will define the energy band and also the atomic number. So if a crystal is formed, so whatever atoms are there, the atomic number of the atoms will also be determining the energy band structure, and these atomic number will basically determine the electrical, you can say, contribution of the atom. So as atomic number is high, that means more electrons will be there in the outer shell, so that will basically more number of electrons are there, so the ability to conduct the current in case of the higher atomic number in the outer cell will be affecting the electrical conduction property of that particular crystal. Okay, so here this higher atomic number, that means it is basically affecting the electrical conduction property. Okay, okay. So now energy as a whole, if we see, like in all the cases, if we combine all the four cases at the final, after reducing all the distance such that we have started with a far distance till the overlap and beyond the overlap, if we combine all the four cases, we will be getting the energy band. So that energy band will be, you can say, look like the energy band explained in the figure B. Okay, so this will be the energy band. So here basically at the D, that is interatomic distance, is very high, that is having a constant, or all the atoms having the same energy level. Okay, as we are going to reduce the interatomic distance, the energy bands will spread in discrete levels. So these discrete levels will be considered as a band. Okay, so this will be one band, this is another band. So these bands are like, if the band is occupied by the electrons, here 4n electrons are there and 4n states are there. So this occupied bands will be considered as the valence band. The empty bands that will be at upper side will be considered as the conduction band, and it will be having whatever states are there, it will be having zero number of electrons. So because here 6n and 2p are 2n are there, so once we are going to form the crystal, as we are going to reduce the distance, the crystal will be formed. So in that 6n plus 2n, 8n electrons will be divided into two different levels. So 4n will be at the valence downside, lower side, and 4n will be at upper side. These four will be occupied by four electrons. So that's why it is called valence band. So these 4n states will be having no electron. That means it will be empty. So it will be considered as the conduction band. Okay. So this is the point at which the crystal spacing is there. So there crystal lattice spacing. So whatever spacing is there at which the crystal is being formed, so this is that distance at which the crystal is formed. So at this point we will be seeing like valence band is filled and conduction band is empty, and there is a state, there is a state where there will be no chance of electrons. So that state is called your energy gap, or we can call it the forbidden gap. Okay, so this is the structure, and beyond that also, if we are going to reduce, the similar structure will be there, like the states, energy states are having forming the same property, like the lower will be occupied and the upper will be empty. So that will be, upper will be forming the conduction and lower will be forming the valence band. Okay, so this is the overall uh, the energy band formation in case of crystals. Okay, okay, so till now we have seen like how the energy band is formed basically in a crystal structure, and in the next class we will see like what is insulators, semiconductors and metals based on these energy bands. So this is uh, the energy band. These energy bands will explain the property of different elements. So these different elements can be divided into three different categories, like it is either insulator, semiconductor or conductor, or we can call it a metal. Okay, so based on the energy band diagram or the energy band structure of a crystal, we will be analyzing its property, whether it could be out of the three metal, semiconductor and insulator. Okay, so that part we will be seeing into the next class. Okay, so if